Hi everyone. What I got here is just a simple motored bracket, but there's a couple of features I want to point out that might be helpful as you continue your build. Um, you notice I got just two gears attached to a shaft and the motor bracket right here that you can see. Uh, I used the water jet and configured um, this bracket this particular bracket out of three pieces. I have this one here that's bent into a U channel right here, and you can see the features. I've cut out essentially this opening right here that provides space for my motor, and then a second bracket that's just bent at 90 degrees right here that is acting as an axle support, which I find extremely important. Takes the load off the output shaft of the motor, prevents cantilever, and improves the engagement of the gear to whatever you're driving, whether it's another gear or the rack, we'll say. So when I bent these up, right, I had to design into where my center lines of each hole here that's provided for the bearing had to be in the same plane. They had to be in the same line. That's super important when you're designing a bracket like this. The foundation of your machine is going to be the motor itself, right? What's driving the device that's providing you whatever action it is for the challenge you've chosen. So this right angle bracket I had to design or engineer into the distance from where this bottom of this plate was going to mount on top of the first plate, where that center line of that hole would be, in order to maintain that axle right there. And it's pretty easy calculation, right? It's the thickness of one and the thickness of the other and where that center line will be. So that's something that you should really take into consideration when you're building a motor bracket, is putting everything in the same line, it's the same plane. That avoids any radial load on the shaft, which essentially is anything like this. Right? If these aren't in line, the shaft is going to want to be at an angle. So that needs to be avoided. Another thing on this was, in order for my output shaft to line up with where these two holes in this bracket and this bracket ended up, I built in some adjustability. You'll notice that the motor bracket itself, this plate that the motor mounts into, is independent from the other bracket. And they're joined together with two screws. These are the outer screws right here. And I've provided a slot that gives me vertical adjustment. When I put this together, I can adjust this vertically to put this all in the same center line. And by doing a little bit of math, I was able to find where that center line of the output shaft was going to be in relationship to the holes that are in this bracket and this bracket. So those are a couple things you really have to pay attention to have success in your drive. Also, you'll notice I used the brass adapter on the output shaft of the motor that provides us a set screw in order to drive this axle. Very important that you put flats wherever your set screw is going to land, and the reason that is if you picture the point of a screw sitting on something radial like this shaft right here, you only have a small point contact, and any torque back to that screw is going to cause it to loosen up, and you're not going to have a good contact point. So what we do is provide a flat for the set screw to sit on. Therefore, you have full point contact on top of your shaft, and that lessens the probability of the set screw loosening. Set screws are like one of those necessary evils, right? Nobody likes them, but we all use them. So there's a couple things that you can do to ensure that they're not going to fail on you, and it's taking the time to put flats on your shafts where the screws are going to sit. So Yeah, it's an important feature is to take the time to construct this properly, and you'll avoid problems further on down the line in your build. All right, hopefully that helps.